Solving quadratic inequalities, part 3. Example 3 says, an archaeologist is roping off a rectangular region of land to dig for artifacts. The region must have a perimeter of 440 feet and an area of at least 8,000 square feet. Describe the possible lengths of the archaeological region. All right, let's look at what we are given. So we are told that they are roping off a rectangular region. That's important to know. And it says the region must have a perimeter of 440 feet, an area of at least 8,000 square feet. All right, and then it says describe the possible lengths. All right, so a rectangular region, we know for a rectangular region, the perimeter is going to be twice the length plus twice the width equals the perimeter. So we can say 2L twice the length plus twice the width. That has to equal 440 feet. Okay, and let's say L equals length in feet. And W equals width in feet. All right, so we're just defining our variables there. All right, now, so let's see what other information we have. So it says the area has to be at least 8,000 square feet. So we know a rectangular region has an area of length times width. So this says it has an area of at least, so that means greater than or equal to. So it's going to have an area greater than or equal to 8,000 square feet. All right, so what we're doing is just basically looking at the given information to get started, to see what we have, and then to see what we need to do with that information to figure out how we can describe the lengths of this region. All right, so we have perimeter. Perimeter is twice the length plus twice the width, and that's going to equal 440. And then we have an area, which is length times width, which is greater than or equal to 8,000. Now, the reason, instead of writing area here, I'm going to put length times width greater than or equal to 8,000, because both my perimeter and my area are represented by length and width, and that way I can rewrite one of them so that I can compare them in one variable. If we can solve for one variable, then we could solve for both variables. But since we're looking for length, that would be maybe what we're going to solve for. So what I'm going to do is take my perimeter here, and I'm going to rearrange this to where I can solve it for either W or L. All right, so it doesn't matter which one, but right now I'm going to solve it for W, because if I solve it for W, it's in terms of L, and then I can plug it in this equation and then solve, and that'll be for the variable that we're looking for. So let's first solve this for W. So that means I need to get W by itself. So I'm going to minus 2 times length on both sides. I'm going to have 2W equals negative 2 times length plus 440. Now I need to divide by 2. So my width is equal to negative my length plus 220. All right, so now if it's in terms of that, I can take this and substitute it in for W here. This is just substitution. If two things are equal, I'm going to substitute it for that. So I'm going to have length times negative L plus 220. That's my width, or equivalent to my width. And now we know that that's greater than or equal to 8,000, which is the area. All right, so let's put this in standard form. So L times negative L would be negative L squared. L times 220 would be 220L. And then let's subtract the 8,000. Let's bring it to the other side. And that's going to be greater than or equal to 0. So now we can assume it's an equation again and look at it like we've done with the other ones. I'm thinking a good way to solve this one may be just to simply graph it. If we graph it, we could actually leave the 8,000 on the other side and graph it as a system of equations. Or we could graph this one and find the intercepts. Since we already have it in this form, let's see if we can find the intercepts here. All right, so let's take our graphing calculator. Now this is in terms of L, but it can be any variable. This is just a variable. This represents length because we're solving for length. But for our calculator purposes, we can just use X. So if we go to Y equals, and we have negative X squared plus 220X minus 8,000. All right. Did I set that as a negative again? All right, let's see. Graph. All right, and again, because these numbers are so large and I have this set to a 10 by 10, it does take a second for it to graph, but if you graph this and there's nothing on here, then you need to expand your window. Since I know that perimeter, area, length, width, those are all distances, I'm going to assume I only need to be in quadrant 1. So for my negatives, I'm just going to move this to a -2. Now my X maximum, I don't know exactly what I need to move this to, but let's start with 1,000. Let's take our scale up to 100. And then our X minimum, again, we don't need a minimum value that's negative because we're looking at distances. All right, so again, I'm going to make this a scale of 100. Let's hit graph. Okay, so now I am seeing 2 lines here. So I know that we don't have to go up to 1,000 on the x-axis to see this. I had this as a scale of 100, so this would be 100, 200, 300, etc. So let's change our scale again. We're not seeing the top of our parabola, so let's say our x maximum, let's say we're going to take it to, let's say 300, because it looked like it was between 1 and 200. And our y maximum, we didn't see the top of our parabola, so let's go on up to 5,000 and see what happens. All right, so it does make our parabola look a little better. We also can see our maximum value here, and our 2 x-intercepts are also listed on here. So this is exactly what we need to see. All right, so if we want to do our x-intercepts, that will tell us what these values are. So I can do second trace, and let's find the 0. Okay, let's go all the way to the left. Now, since my scale is on my negatives is like basically you can't see it, you're going to have to take this below where you can see that point and hit enter, and then bring it back above that point and hit enter again. And it's going to give you a 0 of about 45.97. So I'm going to call this one length because even though it's x, we know that we're working to solve for L. I just had to put x in the calculator. So that's about that. Let's use the squiggly lines again. That represents it's approximate. That means we've rounded this, right? All right, so we need to do that again. We need to do second trace. We're going to do 0. And this time we want to find the other 0. So we're going to hit enter. And then go below where we can see. Hit enter again. 174. So that one's about 174. And again, remember these lengths are in feet. So the approximate lengths of the region have to be at least, let's say, 46 feet and at most 174 feet. So that would be an approximate because we are rounding. Approximate, okay, I think that's spelled correctly. The approximate lengths for this rectangular region would be at least 46 feet and at most 174 feet. All right, and you can choose a value in between 46 and 174. Choose a number like 100. You could plug that in and see that it makes both the perimeter equation and the area equation. Make sure that that works. And then if you wanted to find the width that went with that length, you could do that as well. But since it's an approximate length and it's a range of numbers, depending on what number you choose for the length would determine what value you could use for the width that would still make this true. But since our question said describe the possible length of the region, then this has answered the question. But just be aware that that's how it kind of all works together. All right, the self-assessment, solve the inequality using any method. That means you can use algebraic or use your calculator. You can graph it. Just solve the inequality and then explain why you chose that method. All right, so this is a self-assessment. I want you to try to work A and B and then come back to see if you got the correct answers. All right, so these can be worked exactly like we did the other ones. Put this in standard form, set it equal to 0, solve it like it's an equation, then find the critical values on the number line, check the critical or check the 3 regions on the number line, the one to the left of a point, in between the 2 points, and to the right of the point, and then determine which area represents the solution set. Okay, so if you did that for a part, you should have got that x is in between -2 and 1/2. This is less than or equal to, which means the 2 endpoints are included. All right, for this one, you also would have to add 13x. That's your linear term, so that would go in the middle, and then set it equal to 0. So your A would be 4, your B would be positive 13, and C would be 3. So if you got those numbers out of order, if you got the 3 and the 13 mixed up, then you would get a different answer. But make sure it's in standard form, ax squared plus bx plus c. Set it equal to 0. Same thing, solve using the method you choose, and then find your critical values, and then test points in each region on the number line to determine where they are. And you should have got x less than -3 or x greater than -1/4.